In this video, we are going to start Unit 3, which is on the atomic theory and periodicity. Before we really get into that, though, there is some background information that you need to know. And so notes 3.1 are really just going to focus on some background information. Much of this information is probably a review. Okay, so first of all, an atom. Almost everything we talk about in chemistry revolves around this idea of atoms. Okay, by definition, the atom is the smallest particle of an element that retains its properties. It is important to note that atoms are electrically neutral, meaning the number of protons equals the number of electrons, and we'll talk more about protons and electrons later. And that when we symbolize atoms, such as the symbols we see on the periodic table, we must first always capitalize the first letter in the symbol. And if our chemical symbol has a second letter, we never capitalize that letter. So we see some examples here, things like AU, CU, FE, AL. All of those symbols are symbols of various atoms, and we will see when we symbolize those atoms, the first letter is capitalized, the second letter is not. As we start looking at the periodic table, when we look at where some of these chemical symbols come from, it becomes very obvious. For example, we should be able to figure out why hydrogen has the symbol H, nitrogen has the symbol N, etc. However, some of the symbols are a little less obvious, and many times those symbols are derived from Latin names. So for example, lead has the symbol Pb, which is, or comes from, the Latin word meaning plumba. Okay, it is important that we understand the difference between an atom and an ion. An ion is something that has a positive or a negative charge to it. So recall when we talked about atoms, we said atoms were electrically neutral. Ions are those things with positive or negative charges. In order to become an ion, then, an atom gains or loses electrons. Okay, so the proton of the atom is not going to change at all, but the atom can gain or lose electrons in order to become an ion. Cations are positively charged, okay, and in order to do that, they lose electrons, which seems a little counterproductive or kind of counterintuitive. If we lose something, we typically don't tend on being positively charged, but if we think about the charge of the electron as being negative, then by losing an electron, we end up with more positive charge than negative charge, and as a result, we end up with a cation, or a positively charged ion. Okay, metals tend to form positive ions, and we'll talk later on in the unit about a metal versus a nonmetal and where we locate those on the periodic table. And the other type of ion is an anion. Anions are negatively charged ions, and in order to become negatively charged, they gain electrons. Okay, and typically nonmetals gain electrons. Real quick then, if we review the parts of an atom, we should recognize that all atoms contain a nucleus. Okay, the nucleus is the small, dense center of the atom that has a positive charge to it. The reason why the nucleus is positively charged is because it contains the protons, and the protons are the positively charged particles found within the nucleus of the atom. Also found in the nucleus are neutrons. Okay, they are particles within the nucleus that contain no charge, and in terms of the mass and the size, neutrons and protons are typically similar in mass. Okay, finally we have the electron. The electrons are negatively charged particles found outside of the nucleus. In terms of their size, they are significantly smaller than protons and neutrons. And you don't have to know the exact mass, but you'll notice the proton and neutron mass is 1.67 times 10 to the negative 24th, whereas the electron mass, 9.11 times 10 to the negative 28th. Okay, that is 10,000 times smaller than a proton or a neutron. So there's a significant size difference in terms of the mass and where a majority of the mass of an atom comes from. If we look at the diagram here, we can see the representation of an oxygen atom with the 8 protons and the 8 neutrons in the center. That would make up the nucleus. We can see the relative size of the protons versus the neutrons. And then we have the electrons on the outside. Those arrows indicate the movement of the electrons, and electrons are typically or are found in motion. Throughout this unit, we're going to talk talk about sort of how we got to our current understanding of the atom, and also get into electron behavior. And what we see is that electrons are significantly more important to the atom than the proton.